All right, Integrated Math 3 distance learners, today's lesson is going to be over describing functions. Okay, so at this point, you have already learned about two types of functions. Maybe Integrated Math 2 went over more than just that, but the primary ones that you've been studying have been linear and quadratic. So we're going to start up a list, and while we're doing this, I want you to grab your notebook and go ahead and title it with what you see on here, because it's meant to be interactive. So go ahead and grab your notebooks, go to a new page, and then go ahead and write Unit 1.1 describing functions. Okay. If you need to pause the video to do that, go ahead and pause, and then we're going to go ahead and get started. So the first thing we're going to talk about is the types of functions. So we're going to list out 5 different types of functions that we're going to be dealing with, or at least having to describe this year. The first one you've been dealing with since middle school, that it would be a linear function. Okay. We're going to add some more to the right, so leave yourself some space here, but we're going to stack these up. The next one would be quadratic, which was introduced to you last year. And we did a lot of review in the last video with the review and the Delta Math assignment, where you were factoring quadratics and graphing them and doing all sorts of stuff with quadratics. We have the next tier, which is cubic. Then it's going to go quartic. And then the final one that we're going to deal with is called quintic. All right, so we need to talk about what sets these apart, okay? How do I look at, because here's the expectation for you, is you're going to have to look at a function you'll be given, and just by staring at it in just a few seconds, you can tell what type of function it is, okay? And you'll know what it is, okay? So let's write out, how do you know what these functions are? How do you distinguish them immediately? The snap of a finger. So the linear, we determine all of this by the highest power. So a linear has the highest power of 1. Okay, that is the highest power. We're going to write some more stuff out to the right, so make sure you have space here. Quadratic is a highest power of 2. And hopefully you remember quadratics and you think, oh, it's ax squared plus bx plus c. A linear is y equals mx plus b. It's just mx plus b. There's no power there. ax squared, the 2, plus bx plus c. The highest power was 2. So this trend is going to continue, and I'm going to start using ditto marks here. So highest power of 3. Cubed, something is cubed, it's raised to the 3rd power. Cubic, pretty easy to remember. Quartic. Okay, now this is where it's sort of confusing, because whenever you think of the word quad, you think 4. Quart, of course, is 4 as well, but this pattern continues. Quartic is highest power of 4, and then quintic, okay, that's 5. All right, so what about highest powers of 6 or more, right? Or are there any other special names? Well, really, there's not. Okay, so we're going to talk about how you name those functions, but let's go ahead and let's go a little bit deeper into this linear. Okay, let's talk about linear. So we have another way that we would describe a linear function. Instead of calling it linear, like we don't have to call it linear, but it has a special name because we use it so much. We would call this a first degree function. Okay, so this degree is going to be a very important term in this class. When we talk about the degree of a function, we say, is the degree even, is the degree odd, which function has a higher degree just by looking at it. So this pattern is going to continue. Second degree, third degree, and I want you writing all this down. Sorry, I wrote third here, but it's That's 4th degree. And then 5th degree. All right. So what about all the other functions? So that's as much as we're going to write there. So if you see a quadratic, you can call it a 2nd degree polynomial. I also want to add that. Let's go back up and add that. So 1st degree polynomial. I'm going to abbreviate it here. And so that's how we can write it. So a 1st degree polynomial, 2nd degree polynomial, 3rd, 4th, 5th, etc., etc. And that's how we describe. So we don't have a special name for a power of 6 function. We would call it a 6th degree polynomial. And that's how you're going to do that. That's how you're going to describe this function, the types of functions. So let's make that note. Any power higher than 5 does not have a special name. They are instead called, we're going to make a general term here, nth degree polynomials. Okay? Or you would use, they were instead called nth degree polynomial. So n can be anything. It could be 1,000, 100, 87. It doesn't matter. But if I gave you this example here, so you can write this in your notes, x to the 7th plus x to the 3rd minus 2x plus 4. So we look at that. Okay, what do I call that? Well, look to the highest power. Does it match our list up here with any of the ones with the special names? No, because the highest power is what? Well, it's 7, so it doesn't have a special name, but we would call this a, would say 7th degree polynomial. There you go. That's how we would describe this function. Now, that's just going to be the names of them themselves in general. So we're looking for those powers. Let's talk about some other ways that we want to describe functions. Sometimes we'll use the same exact example. So we want to find what is called the constant term. Okay. The constant term is, and this is on your list of definitions for this unit, for this first part of this unit. Hopefully you did get that defined. If you haven't, throw it on your sheet really quick for me. Constant term, and you can just take this from what I'm saying in the video. I'm not going to write it in our notes here because you'll have it on your sheet. The constant term is the term in the polynomial that has no variable. Okay, so let's look at our example here. What term is that? Well, which one is not a variable? Well, the 4 is constant, so that would be 4. Okay. What is the leading term? Well, the leading term is the one that is up in the front, right? The lead term. Now, it's not that simple. You can add this to your actually, this isn't a definition that you have. Oh, it is. I see it now. Leading term of a polynomial is going to be, here's your definition. You can write it down. It is the term that has the variable with the highest power. Okay, so it's not always going to be in this form here to where it's not always just the first one. So you have to get used to that. What if I had moved this? Oops, let me erase it. What if I had moved this over here? Is it still the leading term? Yes, because it has the highest power. Okay, it's just not in standard form. So the leading term, definition for that, the term that has the variable with the highest power. That's how that's going to work. Okay, so this was x to the 7th. So we know that this is going to be x to the 7th. Then we have another one, leading coefficient. What is the leading coefficient? Well, that is the number in front of the variable in the leading term. So we have our leading term, it's x to the 7th. Well, what is the coefficient? That's the number attached. Well, I don't see anything in front of it. Well, what's up there? Here's a coefficient here, -2. That's a coefficient. I can see it. What's in front of this one? Well, there's a 1 in front, right? So the leading coefficient is 1. All right. Let's try this with another example. Let's go ahead and let me get us another problem here to look at. 1 second. Okay, this is a really good one. We have 3x to the 4th plus 6x minus 1/2 x to the 5th minus 1. Okay, first off, what are we going to name this? What is its name? How do we describe it? Well, I'm going to pause this and you can submit an answer for me. Okay? All right, so in your pause, I'll read your response. The name of it should have been, you have two options for right answers, 5th degree polynomial, or what I would prefer you to put right now is quintic. Okay? A quintic polynomial. Okay. Pause it again for you to figure out what is the constant term. Pause it. Okay, you had time to answer. It should be the number without the variable. So it is all of it. It's not the 1. So if you put 1, you got it wrong. It is -1. Okay. Next question we want is the leading term. Okay. So I'll pause. You can type a reply. Okay. So in the front over here on the left, we have 3x to the 4th. But is that the leading term? No, it's not. It's not the highest power. Here is our leading term. So hopefully you remembered that and you wrote that in however you could. If you put 0.5 and you just wrote in words x to the 5th, that's fine. Or however you typed it should be okay. I'll figure it out. But it's also the negative. So -1/2 x to the 5th. Okay. So what is the lead coefficient? Right. Good. Leading coefficient, the number in front of this leading term, well, it's this 1/2. Well, it has the negative as well. So I didn't pause it there, but that's going to be that answer. Okay, so what's the problem with this? Well, the problem with this is the numbers are not in the correct order. So let's go ahead and do this as well with our example 2. We want to put it in standard form. Which is another definition from your list. So you can add this to it if you want. I'll accept this definition. So standard form means I'm ordering the terms from highest power to lowest, okay? Meaning the constant should be at the end, which in this case, the -1's already there, but we put the highest power first, then the next highest, then the next, all the way to that constant. So let's put this in standard form. It should be -1/2 x to the 5th plus 3x to the 4th plus 6x minus 1. This is the polynomial in standard form. Okay? All right, so that's actually the end of this lesson. That's all I wanted to talk about in this one. You have practice problems over this. It shouldn't take you too long to do. This is kind of a a pretty soft way to start the lessons this week. So go ahead and try those out. It's the first 3 sections, I think, in your Delta Math assignment. If you have questions, send them on Remind or on email.